the amount of displacement of a absorption or emission line. There's also a cosmological a redshift, and that is due to the expansion of the universe itself. That not so much that the stars are moving away, but all of space is expanding like blowing up a balloon. Space itself is getting bigger, and that creates a redshift. There's a third one that's hardly ever mentioned. That's the rotational redshift. So if the entire universe is rotating, then there will be a redshift from that. Unfortunately, we can't calibrate it. And so they tend to ignore that, and it just remains theoretical. But it's out there, and that may explain some things. Okay, the expansion of the universe. That the astronomers have found that the farthest galaxies have redshifts appropriate to speeds approaching a significant fraction of the speed of light. And the expansion of the universe means that it was very small in the past. And so theories were invented to explain the observations. The Big Bang theory is a popular one now. It says that the universe exploded out of nothing, expanding from an infinitesimal point to what we see now. Of course, that violates the first law of thermodynamics, getting something from nothing. Okay, well, modern observations have led to supposed variations in the rate of expansion. And in other words, it hasn't been constant over time, so they say. And so the theorists have invented things called dark matter and dark energy for holding the universe together, for the dark matter and gravitational attraction, dark energy to speed up the expansion of the universe. And both of these, dark matter and dark energy, are not observed. They're just theoretical, that are things that put in there to make the models work. Some of the ideas here that the matter that we can see in the stars and galaxies and stuff like that is only like 5% of the whole mass that's out there. But it may not be true, because it's all theoretical and just forced to, they put it in there to make their models work. Well, you go to the Bible, and one passage there from Psalm 44 says, "I am the Lord who has made all things, who alone stretched out the heavens." Stretched out the heavens is a phrase that occurs 17 times in the Bible. These are the other passages. So you can get these out of Russ Humphrey's book, Starlight in Time. So the expansion of the universe is an expected observation according to the Bible. So it shouldn't surprise us to see an expanding universe. Okay, the Big Bang theory. We have to go into the assumptions on that. And this is covered in Russ Humphrey's books. The Big Bang theory assumes an unbounded universe. It has no edge and no center. It's just uniform everywhere, and there's no preferred location. Having an edge and a center near the Earth is unacceptable to the theory, because in naturalism, the Earth is not supposed to be special. And that's the mindset of those who promote the Big Bang theory. The Big Bang makes the universe out of nothing in violation of the first law of thermodynamics, as I've already mentioned. Another interesting thing is that the initial Big Bang universe had a size smaller and more massive than a black hole. And the black hole, theoretically, nothing can escape from that. So how did the universe ever expand out of black hole conditions? So I haven't heard a good answer on that yet. I think Hawking said that, well, he just makes the equations run in reverse just to get it out there. Even though he doesn't have a justification for that. Okay, there's a cosmic microwave background at peaking at around 2.7 degrees Kelvin that is assumed to indicate a remnant of the expansion of the universe from Big Bang conditions. One problem is that it is too smooth out there to account for the formation of galaxies and clusters. That the theorists said there should have been more lumpiness out there in this cosmic microwave background that would indicate there's some gravitational attraction that will account for the galaxies and clusters. I think that they've said that the smoothness is like 1 part in a million, which is pretty absurd. And the instrument itself can't even measure that, and so they had to do tremendous averaging over lots of observations. Furthermore, recently they discovered that the cosmic microwave background has no shadows created by the blockage of foreground galaxies. And that's a problem that's not usually talked about either, but it's there. The earliest galaxies, the farthest out ones, as I showed in a previous picture, look like modern galaxies, too advanced for their supposedly young age. So these are some problems with Big Bang theory, and they are not being answered, and so there are a number of scientists who are starting to look for something else, thinking that the Big Bang theory is basically crumbling. Okay, the Hubble constant. For nearby galaxies, over on the left side, there's a very nice relationship between the magnitude, that's the absolute magnitude, or the relative magnitude that we can see, and the redshift. So the nearby stars have little, nearby galaxies have little redshift, and the farther away ones have greater. But there's no scale on here to show that those are just the nearby ones. Quasars are out there, and quasars are apparently the brightest objects in the universe, and they're assumed to be galactic cores, though there are some problems with that. Their redshifts are used to indicate great distances from us. So there are some objects out there whereby we can see the light of the quasars, but we can't see any galaxies surrounding them. So they assume that they're just galactic cores. Well, how do they match up? The magnitude of the quasars versus the redshift, and we get a tremendous scatter. And so the Hubble constant is not a good relationship for quasars. Another thing that's being found is that these redshifts tend to be quantized, that they're clustered about orderly successive values. And that means the universe is organized into shells of galaxies, and that the Earth is near the center. And so we say the Earth is right here, and we got a shell of galaxies about there,